Hello, everyone. Happy Thursday. It's 11 o'clock. We're going to go ahead and give a couple extra minutes for people to join us uh, and for us to before we get started there. So, hope everyone's enjoying their Thursday morning. Have a nice cup of coffee. All right, we're going to go ahead and kick it off. My name is Dylan Storey. I'm the Senior Director of Data Science Services at Domino Data Labs. And today I'm going to talk about operational AI readiness. And really the goal here is to discuss techniques and practices to accelerate value delivery. So this is going to be a little bit less about technology and more about people, processes, kind of things like that. Not to say that technology is not important, but there's more to it than that. First and foremost, do want to say we are doing this session to specifically for our public servants, working inside of the public sector. We know that right now is kind of a hard time for a lot of people, and so we want to say thank you for your service. We know that the work you do, keeps us safe, secure, and informed, and it's important to us. And so we want to make sure that we can give back where possible, and this is an attempt to do so. Hopefully, it helps. So a little bit of market context here. First and foremost, AI leadership is a top priority, not just in commercial sector, but inside of the government as well. January 2025, day one executive order removing barriers to AI leadership in AI. April 2025, we had the OMB memorandum on accelerating federal use of AI through innovation, governance, and public trust. And then, most recently in July, winning the AI race, the White House action plan was published. Clearly, this is, an administration priority and an important one for our country. The AI market opportunity is very large as well. Government and defense verticals are typically around 10 to 15% of the total market, and we're projecting that to be somewhere around a 10 to 20 billion market in 2024 with 75 to 120 billion by 2032. The 26 budget request marks the first year in which the DoD has dedicated a separate budget line for autonomy and AI systems, currently at $13.4 billion. So it's not just words, people are putting actual resources behind this. Drivers of this are things like AI adoption mandates. So, the White House action plan, the NIST AI risk management framework, executive order 1110 or 11.0. Workforce modernization and augmentation. So we're trying to find ways of increasing efficiencies. Open data is beginning to get larger. Evidence-based policy is also, it's always been important. It's getting increasingly so now. Obviously, scientific research and simulation and public safety and fraud prevention are all big drivers for why this is a big deal. But there's a reality check. The return on that investment is still very, very hard. From the commercial side, 1 in 4 companies have found value from AI. That's 1 in 4 companies have found value. That's not to say they've even broken even or made a profit on it, but they've found value. Gen AI really hasn't delivered significant returns on investment for enterprises either. So the C-suite's perception, at least, is that Gen AI is affecting revenues and costs, and generally it just isn't really delivering yet. There's been multiple reports over the last year, and there's a variety of reasons for this. But there are challenges, right? So the common challenges that us at Domino have kind of seen over the last years, and honestly, this cycle isn't a new one. It's the same one we've seen repeatedly. You started off with big data, and then it was data science, and then it was machine learning, and it was deep learning, and now it's Gen AI. And it's not to say that it's the exact same cycle, but uh, history doesn't repeat itself, but it often rhymes, right? So what we're trying to do here is there's some common AI challenges, and these may seem pretty familiar to you, not just now, but in the past as well. Generally, the questions here is, do you guys face the following problems? Do you have a time to acquire? Slow acquisition rates. It's too expensive or complex to get started. You've maybe got some clear use cases, but you don't have a clear path to execution of like, hey, we know we've got a use case here. We just don't know quite how to get it over the line. So we can actually see if it has an effect. Time to launch. Onboarding can be really a heavy process and resource intensive. So, in this case, it's, maybe it's acquiring GPUs, it's acquiring technical platforms, it's acquiring technical expertise. This stuff doesn't just happen overnight. It can take forever to get models into production. So, this is a kind of a tale as old as time, is like, hey, we've got these great Jupyter notebooks and these great POCs. How do we get them into a value creation mode and outside of people's notebooks? Our environment is taking months to set up. So again, resource allocation, having places to run these things at. We don't have time or internal bandwidth to plan and launch. Those kind of statements, maybe that's your problem. And maybe it's just time to value, and in this case, my board executives want to see results yesterday. Lots of people are like, hey, we want to be using AI. We want to be using it right now. This stuff does take time. Are you feeling a lot of external pressures to get it done? Maybe you think you have the data science talent, you've built a data science team or specialist in this area, and you're just not seeing ROI. Or a very another common one is your data science teams and maybe IT aren't aligned on delivery, where you have people building stuff that never gets to production because they're not talking to each other. So those are the kind of types of problem statements we're going after to help hopefully solve. And here's some typical workflow problems that we've seen in the past. Scientists are building models in isolation. So they're focusing on accuracy and not operability. So this is the kind of model-centric view. We'll talk a little bit more a little bit. But taking a very model-centric view, if I can build a really good model, but maybe haven't thought about what it means to operate that model and how it affects current business practices and processes or mission processes and goals. Handoff to engineering. So sometimes you build the model and the first time it ever gets exposed to production requirements or when it gets handed to engineering, it hasn't been thought about at all. So this is things like, you can think about it as, maybe your data scientist has built this great model, but it's in Python and it's only been tested and run on large, bare metal clusters or something like that. And it turns out that the model itself needs to be running at the edge, right? It may seem like a really obvious one, but it is one we have seen. As a result of this, you get value delayed, which means lost value. So, maybe as you're struggling through all this, your priorities are shifting during that re-engineering time. So all of a sudden, that investment becomes a kind of a lost investment, and you start dealing with, you know, uh, lost ROI as a result because you weren't able to realize value in time for it to still be relevant. Maybe it's just you have shifting priorities. Problems are identified without an implementation context. So where your agency is identifying the opportunities and it doesn't have or your data scientists are identifying opportunities but maybe doesn't have the full implementation context or the full process context in mind on day one. And so they're missing some very critical piece of information on why this is maybe difficult or why a solution has a yes but kind of in it. There is a formula for success. I'm not going to claim that it is simple. It is very straightforward, though, on how we can help accelerate these things. It's a straightforward concept that has lots of complications and wrinkles that go with it. But start with simple things, make them complex later, right? Or complicated later. And the formula is really easy about maximizing value. It's a function of prioritization, bandwidth, and latency, right? So first and foremost, you need to prioritize your work. POCs need to be prioritized as well. So making sure you're doing the most high value work at the at the time you're working always. Bandwidth is really a function of how many people you can have working on things. And then latency is really the time it takes for you to take that prioritized work, get it through the system and get it into your value stream. I will use the word production repeatedly. Production, when I'm talking about this stuff, does not necessarily mean like a production environment. What I do mean is it's an area where it's creating value. I have worked with plenty of teams where production was maybe even in UAT or testing technical environments, but they were operating their production services in those lower environments because that's where they were providing the value. So if you do hear me say that, please just keep that in mind. So if maximizing value is a function of those three things, what types of activities can we, talk about here. And so I want to start off with a statement of it's not just software, right? You cannot just go out and buy a piece of software, buy a piece of technology platform and say we're done. Technology platforms and software are important aspects of it, right? If they don't support your culture, your organization, your team, then you're never going to get the full value out of them. So after you've maybe solved some of the technical issues or you've identified those, you also need to make sure you have shifts in culture, your organization and your team in order to help you guys deliver in a way. So from a culture perspective, it's really about agility. And this is agility in the truest sense of being able to shift. It's not about shifting all of the time or doing things at a whim. It's about being super structured and regimented for short periods of time or short tranches of work, so that you can shift and then being open to those shifts over time. You need to be focused on speed and value always as well. So even for research heavy teams, this is just a kind of a cultural thing you have to learn how to adopt. From an organizational perspective, then one of the biggest things that we do to kind of advocate for are shift left kind of approaches to work plus iterative delivery. So this boils down to early and often beats late and perfect, right? And so making sure that you're constantly delivering the next iteration to make it better. Um, this is not to really have an argument on agile versus waterfall. There are times and periods where waterfall planning is required. That doesn't mean you can't have this kind of iterative delivery concept in mind while you are doing the actual delivery, though. And then from a team perspective, you want to reduce risk and increase impact always. So you really want to be selecting for proven design patterns. You want hands-on guidance. You want smarter decisions. You want to take on less technical debt. And so these are all the kind of areas that you want to be thinking about outside of just the technology platform. The big one we're going to talk about and focus on today really is around shift left to start with. It's not a new concept, but it's one that I think does deserve a little bit of extra time to be discussing about. So first and foremost, what is shifting left? It has its origins in software testing. It's a concept borrowed from an engineering discipline where really what we do is you start moving early or critical activities earlier in the process. So if you think about a process as being left to right, left being early, right being later in a process, especially like maybe delivering a piece of software, shifting left means that you're just moving certain activities to the left. Your other question might be, can you shift right? Yes, you can. In fact, sometimes you will move certain activities both left and right at the same time and move them to different areas. But really what it's about is it's about making sure that you're in this context, we want to start moving operational concerns to the beginning of the life cycle. So we actually want to start making sure we're marrying up how we deploy and operate models to also how we're doing research on them at the same time. And so this is things like, in this case, sometimes it is testing, right? But it's also about having early architectural decisions earlier in the research process so that you can start, ruling in and ruling out certain techniques and capabilities that you might want to be trying out from a research perspective. That'll also get us into risky assumption tests in a little bit as well. So in this case, it's about having an engineering mindset, even as a data scientist earlier on. It's also about having a collective and collaborative approach always. It's not just about data scientists need to learn how to be engineers. It's about inviting engineers, inviting operational components of what it means to go to production into the process as early as possible so that they can be heard and they can also be learned from. So this is also an area where like governance fits in really well. Often you'll see people wait for governance as a last step before they go to production, when really what you want is you want governance in there day one so they can help you understand how to keep yourself safe and make sure that your systems, as low risk as possible before you go to production or start trying to move things through. And that way they become less of a bottleneck and more of a partner. So the first thing we want to talk about then is decreasing latency. What are some techniques and processes that we can use to help make sure that we decrease the amount of time it takes to go from idea to value? One of the biggest ones is a team organization. In a traditional approach, we often see siloed departments that are creating costly handoffs and delays. And so the way I generally think about this is every single time I have to take a work product and hand it between teams, just assume there's going to be a long conversation, right? And so, tell me if you've seen this one before. Data science teams building a model in isolation, they hand it to the engineering team. The engineering team almost immediately says, I don't understand what any of this code does. You handed me 15 Jupyter notebooks that are out of order. It looks like you might have even been running the cells in a specific order that wasn't top to bottom. And so I'm struggling to even understand what it means to implement this. And then later on, you get down to the operations team, and all of a sudden security gets involved and says, hey, you're using this library, doesn't meet our open source requirements. Or, maybe is using a license that we can't support if it's legal. Or maybe it's governance, and they say, hey, this data set that you're training against has some pretty serious problems with it. We need to go back and try again. And this is after you've done all of your research and maybe even gotten through engineering to some extent. All of a sudden, business value gets delayed, by months if you're lucky, potentially years, or just never gets delivered at all. In a shifted left approach, you start building cross-functional teams from day one. You focus your teams around domains that own full delivery, and so I refer to those as value streams. So that value stream might be, I'll use a corporate example here. Maybe it's not necessarily, it's customer retention, right? So you're not focused on a specific model or anything like that. You're focused on that business activity, or that overall operational activity of, how do I retain people, or how do I detect fraud. And then you have your engineers and your scientists as part of a larger team that are all working together with that overall context, right? So, whatever the mission is you're all aware of and understand that context, and you're all working with each other and meeting regularly so that you can discuss things openly and honestly. That way, business outcomes work is constantly being aligned to those business outcomes, and hopefully you can start working on weekly cycles instead of handoffs between teams. Again, security and governance are part of delivery, so you want to make sure that they're in there as well. It does not mean that they need to be fully embedded, but they need to be invited, aware of what's going on, and active participants in all work. So before, often see a lot of the handoff model where I'm done with my part, documentation gets transferred between stage, communication bottlenecks between teams. Teams are blind to assumptions and requirements of the business sometimes, or the agency, and then blame shifting kind of occurs here. So if you start seeing lots of blame shifting between teams of why things don't happen, that's a good indication that teams aren't working with each other. They're simply funneling work, right, between each other. Afterwards, you start seeing a shared ownership model where end-to-end responsibility starts driving better systems. So, operations scientists, the business, your engineers are sharing solutions, solution definition and context with each other at all times. Communication loads start to drop because everyone has a much more complete picture of what's going on where possible. And then you also wind up getting early and often feedback cycles start kind of forming very organically as a result of people who are, quote unquote, later in the process as far as the value delivery aspects go, are immediately working in the same room with people who are upstream, and they can start sharing ideas and feedback with each other quickly. Another kind of a happy thing that comes out of this is often you wind up getting joint response and resolution to incidents. So in technical systems, things do break, and because everyone's in the room with each other, you start seeing more nuanced resolutions and ways of dealing with major incidents, so that everyone has that shared responsibility of how do we fix this and make it right. It's not just on one team to try to do their aspects. The next piece is to switch from more of a model-centric to that system-centric thinking. In a model-centric view, you often see that scientists are optimizing algorithms in isolation, right? So they're focusing on the model accuracy and the architecture of the model itself. They're optimizing for performance in lab environments. They're treating deployment as an afterthought as a result. This is not to say all scientists, but this is just a behavior that you generally see. And then value starts getting measured by technical metrics, right? Oh, we're delivering at so many milliseconds. Our F1 score is Y. And you're not necessarily thinking about how that model sits in an overall system here being not necessarily a technical system, but just an operational system of some sort. um, Models exist as components in operational systems when they do provide value, right? They're not operating in a silo by themselves. No one takes a pickle file and puts it somewhere and it magically creates money. It's got to get talked to, it's got to get interacted with, it has to be able to make decisions, right? So it has to affect the world outside of it somehow in order to make it useful. um, in a system-centric view, you're considering production context from day one. You're designing for integration and monitoring. You're building with operational requirements in mind. So this might be something as simple as SLOs, all the way to SLAs, or even understanding that there are escalation patterns that need to be built in early on to make sure that maybe people are alerted at certain times or escalation paths are honored. And value winds up getting measured in business outcomes, not in model metrics, right? It's not our F1 score is really high. It's, hey, we're able to drop the time it takes for us to resolve an incident of fraud by 30%. And so those are the types of outcomes you start seeing when you start shifting from model-centric to system-centric views. Some approaches that help with latency, we strongly believe in visualizing your work, so making sure that your work is always visible. You know what people are doing and what activities are being worked on. We find Kanban tools to be very, very useful for this. It's what they were built for. It's what they're designed for, and they are great at it. It helps expose bottlenecks. It helps slow down value delivery as well. You can start seeing if things are piling up in certain phases inside of that Kanban board, and it will allow you to understand if you need more resources or if there's some other larger issue going on. You want to limit WIP on people as well, work in progress, sorry. So you just want to make sure that's a constraint always of like, hey, we don't have more than a certain amount of tickets. Something I always like to point out with work in progress limits is it's not meant to be a hard thou shalt not. It's meant to be a status indicator, right? When you break a threshold in your WIP limit, you should ask yourself, do we need to increase our work limit, or is something else going on here, right? It should trigger a response, not just be a we don't do it. You also need to make sure that you just got good definitions of done. Understanding what it means for something to be done allows people to plan better. Being able to plan better means you can execute better. Being able to execute better means that, because you know what you're going to go do, you don't have as many go back and do X or Y or Z again, or things don't tend to linger. You don't have those long-tailed pieces. And the last piece there is just, always keep a pull-based system. Try to limit the amount of push down work that happens and allow people, individuals, and systems to pull work as they are ready to do it so that they can actually complete things. When people start, and I say people here because it is people, start pushing extra work into the system, like I need to get X, Y, or Z done, it creates bottlenecks because the system isn't necessarily designed for it or people aren't ready for it. So you just want to make sure as much as possible you're keeping that pull-based cadence so that people are pulling work as soon as they're ready to do it. Keep yourself just in time. Next big one that we've found a lot of value around is, again, refining prioritization. This is a really important one. Being able to prioritize work effectively is important so that you can not just rule out what work you are or aren't going to do, but also allows you to do things like get work that's maybe going to fail out faster so that you're not investing time where it's maybe not returning as well. And so the biggest one we want to just discuss about here is failing fast. One of the things we found is that often people will they'll wait too long to figure out that something's not going to work, and that cost of failure increases the longer you wait. So if you wait until you're at market and you've got something in production to find out that it's not working, right? You're looking at quarters to years to fix something, and that's often fatal to projects. Right at that point, it's, hey, we're just going to shut everything down and we're just not going to try to fix this at all. But as you start progressing backwards, things get less expensive to fail. So you want to make sure you just push all of your failures to the left as much as possible. So you really want to start with assumption failures. You want to be able to, like, as you're identifying work to do, find your assumptions in there and do what we call risky assumption tests. So you rat it out, right? You take you identify risky assumptions of a piece of work, and you go do what you can to find ways of getting to failure modes as quickly as possible, so that you can rule out work before you progress it through the system and start investing a lot of effort into it. And then as you go up the thing from assumptions to design, implementation, and market, you're just kind of constantly looking at that part of, like, does it make sense to continue moving on? And you just want that to be a very direct and a very thoughtful conversation of, should we do this? You want to be deliberate about it, right? And the answer might be yes most of the time, but it's important to ask the question and say, should we continue? And yes, we should. Cool. Move on to the next kind of phase as we continually invest in things. Some approaches that kind of help with the risk management. You want to try to treat your solutions as testable ideas rather than absolute answers, right? So basically, just make sure you're constantly thinking of things as hypotheses or maybe theses in general, and just have that mindset of uncertainty, right? Don't have yourself chained to an idea constantly. You want to test those risky assumption earlys. We kind of covered that pretty heavily. The next thing is you want to create those learning cycles as well. You want to make sure that your learnings are fed back into the system and disseminated where possible, especially the negative ones. And I know that's can be very, very hard. It's much easier to get ahead in life and feel better is when you have positive things to report. But you do want to make sure that your small iterative experiments that fail are visible as well, so people understand, maybe what not to try in the future or prior art that didn't work. And again, you want to focus on value delivery. You just really want to abandon unproductive paths despite your previous investment. Direct resources towards approaches that are demonstrating impact and just kind of double down where it makes sense, but don't be chasing what bad money after good, if you will. And the last one is really around scaling. It's how do you increase bandwidth? Everything we just talked about is really, really easy to implement at team level. It's something you can probably start inside of a week or two of finding ways of adapting this into just how teams work today. Teams being units of maybe 10 to 15 people. But obviously, no one works in a silo, right? You have to work across teams and organizations and agencies. And, how do you start thinking about scaling these kind of thought processes out over time? And so the biggest one is that you want to make sure you kind of create some sort of information sharing system where you've got usually three levels functionally. At the end of the day, you might have more than this, just depending on the size and scale and complexity of your organizations. But really, you've got those three levels where you're doing strategic planning, and this might happen on the yearly level and be revisited once a quarter, to just basically say, hey, here's the objective, here's the mission. And every quarter, are we on mission? How, getting status updates. That's how it flows up. And at the same time, as you're looking at that strategic overview, you're making decisions of, all right, we're going to keep a closer eye on this. We're going to be making a decision in the next 6 months whether or not to continue, or hey, this is going really, really well. What if we, invested a little bit more in it? Could we get more out faster? At the next one, you have that value stream coordination level. This is really about taking the big strategies and turning them into operational, not operational, but more like tangible deliverables that you can kind of work against and goal wise. And so this is generally where teams start working on things across multiple teams to kind of achieve the strategic objectives. And so this is just the area where you're coordinating maybe multiple teams together. And then below that is your delivery layer. In software engineering projects, this is where delivery teams work. This is where you have your Kanban board, you have your tickets, you're breaking epics down into stories, if you will. Some really, really important things here is just, again, it's feedback loops. You need to make sure you have communication going up and down at all times, and so you've got meetings for that. You want to do this in a way where you're eliminating organizational silos by creating those clear communication pathways, right? So you define your communication pathways, you define your interfaces, and you make sure people are in the room. And then by doing this as well, you can help identify systemic bottlenecks. So because your value stream, coordination group probably meets once a week at least, you can start identifying, hey, like we're seeing, this work is slowing down because we're waiting on an external third party to kind of finish something, and you just be aware of it and then communicate it up. Like, hey, strategically we've got this issue going on. It might slow us down, or maybe it's one of those things where because you're having that conversation in a large group, somebody can say, hey, I've got an alternative. Maybe we can try this out since this is taking too long. Again, you really want to make sure you want to balance team autonomy with strategic alignment. So make sure teams are able to make their own decisions as long as their work is aligned against the strategy at all times. Um, and then the way you deliver on this organizational change is really you prove value with, maybe you start with we call these 0 to AI engagements for anyone who's curious at Domino, where you just start and deliver your first systems in maybe a 10-day period, and really you just want to start by demonstrating tangible business impact that, like, hey, these types of delivery mechanisms can provide value. This helps build confidence and momentum. After that, you can start thinking about scaling. So you're really taking a bottom-up approach here, and you expand from a single project maybe to multiple value streams, where you start with that one simple value stream and then start expanding it out. Maybe it's multiple value streams within the same team, maybe it's across multiple teams, but you start establishing those repeatable delivery patterns then within your smaller organization, and growing it out, and helps you again refine, because every organization is different. Helps you refine what's best for you, and you start building those cross-functional capabilities, start establishing those meeting cadences, etc. And then you can go on to transform your organization from there. And that really is just a function of everyone starts doing this, and changing the way they work, and it kind of self-organizes from there on out. And you'll start seeing an embedded culture of velocity and iteration by building it from the ground up that way. You do, of course, need top-down support in order to achieve these changes. When you're measuring success, we often see things like, before people have shifted left and kind of gone through this, 6 to 12 month time to production can drop down to 2 to 4 weeks very quickly. Um, you start seeing, production success rates at 20 to 30%. All of a sudden that number changes rapidly. Some of this is because you're failing out work faster, but also because maybe your definition of production is changing a little bit to be more aligned to what's the value, and not necessarily it's running in a specific system in a specific way. Um, you start seeing, going from quarterly or very long updates to short, small, iterative updates, so that you're constantly making little bits of progress instead of trying to make one big group of progress over a longer period of time. And you start seeing more cross-team engagement. Some common pitfalls to avoid as you're thinking about this stuff. Tool obsession is a big one. New technologies don't fix cultural resistance. I think everyone knows this, right? We all know this, but we always fall into the trap. It also feels like, and we also see everyone, people fall into this trap all the time. So this is the biggest one you probably want to pay attention to. You want to be careful about unrealistic expectations. Um, you need time and support to develop these types of capabilities. It does not happen overnight, right? It can happen quickly, but it does happen in small pockets and will grow and compound over time. You want to make sure that you're playing that balance between rigidity and flexibility required for experimentation. Not just experimentation in the technical sense, but also around how you work and how you try to deliver things. You need to be able to try things out in order to see if you should shift a process, right? Always in making sure that your technical decisions are aligning against the business or the mission that you're supporting, and just making sure that you're providing support during these times as you're kind of making maybe these process changes. Now, I've been sitting here talking about this. Don't just take our word for it, though. This is not something that's brand new and Domino only knows about. This is something that multiple organizations have gone through. Maybe you've heard of them. This company called Uber did this, and before their transformation, they had lengthy cycles. Afterwards, the development cycles accelerated by 10x. So it went from months to days. Key changes: they did build their platform, Michelangelo, right? They talk about this very openly, but that supported a cultural change, right? They pulled an inverse Conway, and they built a platform that supported the cultural changes they needed so that people could move faster, right? Not just technically, but from process and communication perspectives as well. Steward Healthcare, again, very similar one here. They had frequent production incidents. They had extensive engineering rework required to get to production, slow pathway from insight to implementation. So what they wind up changing, they became more efficient and proactive as a result of this shift left kind of mentality, and taking on an agile mindset to not just software, but to research as well and how we deliver it. We're able to establish a model for delivery against specific infrastructure. We're able to help their data scientists understand what production looked like, and since they had a concept of what they were moving towards, we're able to move towards that much faster. Last one I'll discuss about Ecolab. 12-month deployment cycles, communication barriers between large teams. Manufactured insights were trapped in development and we're getting into production. So they were able to get their deployment time cut to 30 into the 30 to 90 day cycle instead of years or never. And they were able to get manufacturing efficiency improvements into production at all. right? That's actually a big deal. And they were able to increase their cross-functional team collaboration, right? So what they do, they unified ML ops, which is a process, not a set of technologies. Were able to help with that transition from development to production. They were able to standardize their infrastructure, automated deployment pipelines. Again, all these are things that are technical changes that supported that cross-team communication and collaboration by having unified architectures. You can have unified conversations as well. So TLDR for you, how do I get started, right? Questions you should be asking yourself as you're thinking about this stuff. Do you have a good understanding of production? Do your data scientists understand the environments where their models are going to be running in? Do they understand the processes that they're going to be working within? Do you have early collaboration? Are engineering and operations part of your research cycle? Are they helping not just drive, are they helping drive those conversations? Are they in the room to maybe provide feedback and their insights as to, well, how this is how it works in the real world? Do you have a definition of success? Right? Is it more than it would be cool if, but you actually have a metric that you can say, a business metric or an agency metric that you can say, we want to shift this needle. Um, do you have a deployment rate? Do you know what your deployment rate looks like? What percentage of your developed models are actually reaching production systems? And this is an important one, so you can just understand the success of your program if you're implementing something. If you guys come out and you start with this deployment, our deployment rate's at 95%. You maybe don't have a broken system that you need to change, right? But if your deployment rate's really really low, then it kind of begs the question, right? And the other thing you want to know is like refresh cycles as well. How frequently are production models being updated, right? This is kind of an important one as well. Just how often do you need to change? What's the variability of your data look like, etc. From there, really key takeaways are you want to center on problems, not frameworks, right? Address your real business pain points rather than implementing technologies for their own sake. Again, I know this feels obvious, but it's one that it's an easy trap to fall into, right? We go to where we're comfortable, just making sure that you're constantly keeping not just yourself, but your teams centered on the business problems. Why are we doing this work? What and why is some of the most important questions about work identification. And they're also sometimes the most boring. They're the least, maybe less exciting. But this is the most important thing. So being able to focus on that constantly is important. Start small, learn, then scale. Don't try to jump into the deep end on any of these things. Having a good agile experimental kind of mindset is critical to be successful here. So start with small things, learn from them. You know, myself talking here, reading a book, they'll give you ideas. They will not answer probably your specific problems. Everyone's problems are a little different. So they might give you ideas of how to go tackle problems, but you really want to start with small incremental improvements, learn from those incremental improvements, what worked for you, what didn't, what do you want to start doing, what do you want to stop doing, what do you want to continue doing after you've made those little changes. As you kind of learn and kind of turn that into your best practices at your organization, then you can start scaling them out much better. You want to build your teams around value streams. So again, you don't want to necessarily say like, I've got a data science team. It's hey, I have data scientists that are part of a team whose goal it is to do X, right? It's not that you have a data science team. You have a team whose goal is to do the mission or your outcome, and you have data scientists, engineers, business analysts, managers. Everyone's around that value stream. And then you want to design for production from day one. This may sound like gold-plated architecture and stuff like that, and so I want to be really careful about this. It's not design in the sense of building out the full system before we go to production. It's understanding what production looks like, and again, not just from the technical sense, but from the operational senses as well, so that you can be prepared. I think a really good example of this one is actually the Netflix prize from years and years and years ago, where the winner of the Netflix prizes solution never went to production. And I don't think it was the winner's fault either. They were handed a data set and they built a great model, but they didn't necessarily know that the production system couldn't handle running a PCA before every single training iteration. Right, it was too much, and so as a result, the technical selection was not incorrect for the solution that was being presented, but it was incorrect for the production system that it needed to go into, right? And so, Netflix paid out the prize. They learned a lot. They've been open about it, but was never actually went into production, even though it was a very, very good solution. So you want to identify your pain points. You want to select that strategic pilot. You want to assemble a diverse team, around stakeholders. So you want data science, engineering, the business. You want to define your clear interfaces. How do you guys talk with each other? How do you guys talk with the people above you at the strategic level? How do you implement your feedback loops? So you want to make sure that the upper levels and lower levels of communication are constantly talking across each other and on a cadence that makes sense. You want to track your metrics for both things like delivery velocity and production health. And then you want to share knowledge. That last piece is really important. It does not work to do this, as a small team in a silo. You want to make sure that other people around you learn from your experimentations and your failures, so that they either avoid them or understand what it looked like. And with that, I'd like to thank everyone for their time today. Just so everyone knows, I cannot see chat. We do have people who are funneling questions back to me, so I would love to take questions for the remainder of our session. If anyone has any, you can place them in chat, and they will get shuttled back to me, but I cannot see them directly at this time. All right. Well, thank you everyone for joining us today. It's been our pleasure to have you here, and I wish you all the best Thursday possible.